Alrighty, also 9.3 deals with exponential functions. And graphs. All right, y'all. So they start out introducing you to another constant, sort of like pi. So this constant looks like a little e, and they call this Euler's number. And y'all, this is a constant that they use in a lot of investment and problems like that, okay? So we don't have to know much about it. We just got to learn how to evaluate it. So on our calculator, we can evaluate E, okay? So I'm going to show y'all where E is on your calculator. So y'all, if you look right above the divide sign on your calculator, there's a blue E. So if you hit the blue second button and the divide button, it'll bring the E on the screen. And then when you hit enter, you'll get its approximation. So they like you go in 4 decimal places. So this one will be 2.718. So the 4th decimal place has a 2, but after it has an 8. So since the 8 is 5 or greater, we round that 2 up to a 3. All right, so they're going to have us playing with the E a little bit and evaluating it. So y'all, let me show you what we're going to look at. We're going to go on the math lab real quick. So like number 1, they want to use a calculator to approximate the exponential expression to 4 decimal places. Now, when it's got an exponent like that, let me show you, there's 2 ways you can do that. You can do it with the E I showed you. You can hit second, divide, and then use the little upside down V for your exponent and put in your 4 and enter. But I'm going to show you another way when you got exponents. On the left side of the 4, you see that LN. Above the LN is a blue E with an X. If you hit second LN, it brings the E up ready for the exponent, and you can put your 4 in and then enter. All right, let's see. If we rounded that off, 0.5981. There's a 5 after the 1, so we would round that to a 2. All right, so you would go put that in. So 54.5982. And y'all are doing one with a negative exponent. So this is e to the negative 3.48. So y'all go punch that in. And I'm just going to do second LN to get that e with the x. And then put in a negative 3.48. So I'm going to round it off 4 decimal places. So this will be 0.030. So the 8's in the 4th spot. Got a 0 after it, so we'll keep that 8. So 0.0308. So we would go put that in. And y'all, that's the trick on those first 2. So now we're going to start looking at graphing. So let me go back to my pad. So they just wanted to familiarize you with the little e, because you'll see it later on in this chapter, okay? So let's look at graphing exponential functions. All right, so those will look like this. Y equals A to the X. So on exponential functions, your variable is the exponent, okay? So the A, we call that the base. And then remember, that is our exponent. Okay. So there's a few things about exponential functions. If this is a zero, anything to the zero power equals 1. So that means when you're looking at these graphs, if you make x 0, if this is 2 to the 0, 3 to the 0, 4 to the 0, it don't matter. If that exponent's a 0, then that value is 1, which means all these graphs go through the point 0, 1. All right, another thing about these graphs, they're continuous. That means there's no vertical asymptotes or none of that fun stuff, okay? And then another thing about these, one side of the graph has a horizontal asymptote with the x-axis. Okay, so there's two ways these graphs will look. And then let's do one with a fraction. So y'all, if the base is a integer or a whole number, then these graphs, they make the horizontal asymptote on the left side. And remember, it's going to go through the point 0, 1. So it makes a horizontal asymptote. It's going to come through that point 0, 1, and then they start going uphill. Okay. Like if this was a 2, 2 to the 0 would be 1, 2 to the first would be 2, 2 squared would be 4, 2 to the third would be 8. So as the exponents get bigger, this graph goes up towards infinity, okay? Now, if you got a fraction here, these graphs, they still go through this point 0, 1, but instead of going uphill, these graphs will come in from the left, go through that point 0, 1, and then they try to make a horizontal asymptote going to the right side on the x-axis. So fractions go downhill, integers go uphill. So what they'll have us do, they just want us to pick out of one of their 4 graphs what these pictures will look like, okay? All right, y'all, so let's go to the math lab and see what they got. So y'all, this one says y equals 4 to the x. Based on what we just drew, this would be the case where you got y equals a to the x. And we said that these graphs would go uphill, left to right. So y'all, it's got to be b. But let's verify that. So we can go graph this. So I'm just going to go to my calculator and go to y equals. So I had, what was that, 6 to the x? So I would hit my 6 and then go up with my exponent and put in my x. Oh, you also will hit graph. Oh, let me get my window set back. I forgot we had this set with what we did the other day. We'll make that -10 and 10. And then I got -10. All right. So there you go. You see it's coming through and it's going uphill to the right. And that was the first picture we drew where it sort of went uphill, left to right. Now, depending on what the number is, determines how quick it gets real steep here, okay? Oh, also on that, we would have to go with B. And then you'll check your answer. Hey, y'all, so that's all they wanted y'all to do on that. Just see what the graphs look like. So now we're going to get into the tricky part of this section. And this is the transformations. And y'all, the transformations are like we did in 7.2, where we moved the graph up and down, left and right, and we reflected it. So these are some more transformations with the exponential. So transformations of exponential graphs. Remember, these are in the form of y equals a to the x. All right, so if you remember before, we could go up or down, we could go left or right, and we reflected across the x-axis. Well, the exponentials, they do vertical shifts. So to do a vertical shift, you'll have y equals a to the x plus b. And it was just like it was in 7.2. If you added a number at the end or subtracted it, it went up or down. All right, if the b is positive, then the graph is going to go up. Same thing as it was in 7.2. If the b is negative, then the graph is going to go down. So that move is the same as it was in 7.2, okay? So the horizontal is going to be a little bit different. Because in 7.2, when we did a horizontal shift, we were attacking the x inside parentheses. Well, y'all, the x is now an exponent. So to go left or right, you'll have y equals a to the x plus c. So you're still attacking the x, but it's up here as an exponent now, okay? So notice the difference. This b is being added at the end of the function. C is being added to the actual exponent, okay? But y'all are still backwards Because if C is positive, so if C is positive, I'm still going to go left. And if the C is negative, then we're going to go to the right. So the horizontals are always opposite what you think. When you add, this actually goes left. When you subtract, it'll go to the right, okay? All right. We can still reflect over the x-axis. So to reflect over the x-axis, we'll have y equals negative a to the x. So just like in 7-2, if we put a negative in front of the function, it reflected it over the x-axis. But y'all, here's the new one. This is reflect over the y-axis. So to reflect over the y-axis, you'll have y equals a to the negative x. So the x-axis, you put the negative in front of the function. To reflect over the y-axis, you put the negative in front of the exponent. So on these problems, they'll give us a base, and then we got to figure out what the move is doing, okay? Now I'm going to show you these on MathLab because they're really tricky to graph. There's a few things you got to do with them, okay? So y'all, let's go to the MathLab. So this one has f of x equals 2 to the x plus 5. So let's play with that just a second. So the base is 2, and we're adding 5 to the x. So here, that's this horizontal shift when you're adding to the x. And we said if it was positive, you're going to move left. Well, that is positive. So this graph will go left 5 units. And y'all, that's the only move we got. So let's go graph this and see what happens. All right, so we said shift left. So that would be B, where it says shift the graph 5 units to the left. And we got to put our base here. So we're starting with the graph of y equals 2 to the x. So whatever number's in front of the exponent, you bring down here. All right, so once you do that, you got to check your answer. And then we got to graph this. So I'm going to click to enlarge graph. So the exponential, y'all, you're going to use the second row. The second tool says exponential. You click on that and then click on the graph. It's going to start it like a basic graph going through 0, 1. So we went horizontally left. So take the horizontal shift, move that to -5. As you move it, the graph moves left. Now, y'all, here's where I get a lot of people. You see down at the bottom, it says base. Well, by default, it's got that little E down there. You got to go in and change that E to match the base of your problem. So since my base was a 2, I got to switch that E to a 2 down there. If you don't switch it, although your graphs look the same, it will be wrong because it's doing it at a different value with that E, okay? So make sure you change that base down there. Then you save it. And then you can check your answer, okay? Hey, also, I got the same thing. 2 to the x plus 4. So this one wants me to graph it first and then describe it. So what's happening is that plus 4 being added to the end is a vertical shift. And we said if that was positive, it would move me up. So we're going to click the enlarge graph, grab our exponential tool, click on the graph, and that went vertically up 4 because we were adding 4 at the end. So take your vertical and go to positive 4. And y'all remember, down here on the base, see I got that E again. I need to change that E to a 2 to match my graph. So then I would save that. So it makes you check that answer before you can move on. And then it says the graph of f of x equals 2x plus 4 is the basic exponential function y equals 2 to the x, and then shifted up 4 units. So it matches what we did to the graph, and we would check our answer. So it's not too bad. You just got to use that chart of the moves we got. All right, so y'all, this is the last one. And all we got to do is describe what's happening. So we're going to start with the graph of y equals 2 to the x. Now that 5 is being added to the x. And we said if you added to the exponent and it was positive, you're going to move left 5 units. And then shift it blank 3 units. Well, y'all, that 3 is being subtracted from the end of the function. And remember, when you subtract from the end of the function, that's going to move you down 3 units, okay? So then you check that answer and move on. Oh, we had to graph this, I guess. Okay, so I guess we'd actually got to graph it. So click the enlarge the graph, grab your exponential tool, click on the graph. So y'all, the plus 5, we said would move me left 5 units. So I move my horizontal left to -5. And then my vertical would go down 3. So move that to -3. Then remember down here on base, change that from the E to a 2 to match your base. All right, so once you do that, you save that, and you're going to check your answer.
But it's not, it didn't go through the 0, 1 point.
Do what now?
It doesn't go through the 0, 1.
Well, let me show you. Let me do this again. So let me play with this. And so this would be what? 2 to the x. And then you're going to shift it left 3 units and then shift it down 5. So what you got to realize on these, Aaron, is when I do the enlarge the graph and I click this exponential tool, when I first put it on the graph, it's going right through that point.
Correct.
So when they're talking about going through 0, 1, they're only talking about the basic graphs.
Okay.
Now, when you start adding to the exponent and subtracting at the end, that's moving that graph around. Okay. So let me go down here and my base is a 2 again. So my horizontal went left 3, my vertical went down 5. Now, see, at this point, once I've done all my moves, that thing's not nowhere near that 0, 1, okay? But there, yeah, when you was looking at that y equals a to the x, we were talking about like our basic graphs before we had any moves done to them, okay? All right, so we're going to play with some formulas real quick. All right, y'all. So this next formula is an exponential function that can find the amount in an account after T years. So let's see, this is like investment stuff, okay? So the formula we're looking at is A of T equals P times 1 plus R divided by N, all raised to the N times T. So since time is the variable, and you see the T for time is up here as an exponent, this is an exponential function. So A of T is the amount in your account after T years. So this would be like you went to the bank and you took out a loan, okay? And this would tell you how much money's in that account after so many years. P is your principal or your starting amount. How much are you investing? Okay. So if I wanted to go invest 5,000 on a CD that paid me so much interest and all that fun stuff, I would use these kind of formulas, okay? R. R is your interest rate. Now, when we use this in the formula, it's got to be in decimal form. So to turn percent into a decimal, you move the decimal left 2 places, okay? N. N is the number of compounds per year. That's sort of like how many times are they applying interest per year, okay? Now on this, they'll use words like annually, which would be once a year, semi-annually, which would be twice a year, quarterly, which would be 4 times a year, monthly, which would be what, 12 times a year, uh, daily. So they'll use different words up here for the number of compounds. And then T is our time in years. Okay. All right, y'all. So let me play with one of these examples for you. So let's go look at Math Lab here and let's see what they've given us. So they're saying $61,000 is invested at 3.5% interest, compounded quarterly. So look what they want. They want me to find the function for the amount to which the investment grows after T years. So y'all, let's go do this. So let me go back to my pad. All right, so here's our formula. So let's just plug in stuff. We know P, which is our starting amount, that's going to be the 61,000. So our A of T will equal 61,000 parentheses 1 plus R. So y'all, R is our interest rate. Well, they're giving me 3.5% interest. So what I'm going to do is change the half into a decimal. And I'm going to make this 3.5. So to turn 3.5% into a decimal, you got to move this decimal left 2 units. And y'all, that means on this one, I would have to add a 0 so that this becomes a 0.035. So this is what you got to put in for your R. 0.035 divided by N. N is the number of compounds. They said this was compounded quarterly. So quarterly would mean that that is 4 times a year. Now close parentheses, and then my exponent would be the N times T, which would be my 4 times T. So now that I have a formula, if I know how many years pass, I can find out how much money is in that account. Now, y'all, the only thing we got to do to put this in MathLab is this 1 plus 0.035 divided by 4. That has to be simplified right here. So let me see what that equals on my calculator. So that was 1 plus 0.035 divided by 4. So I'm going to hit enter. And that equals 1.00875. So y'all, to get this right in MathLab, we have to simplify this part inside the parentheses to this, and then bring down my 4t. This is now what MathLab wants, okay? Now, this is now the formula that if I know how many years pass, I can see how much money I have in my account. All right, y'all, so we're gonna go put that in. So it was 61,000, and then parentheses 1.00875, close parentheses, and then our exponent, come down here and hit the exponent, and that would be a 4t. So this is how you got to put it in. So when you check your answer, all right, y'all. So let's continue. So now they want to know how much money is in the account at t equals 0, 3, 7, and 10. Now, I'm not going to lie. You can do this 4 times by putting each number in here each time. So like for 0, you can come up here and do 61,000, 1.00875, and that'll be 4 times 0 for your exponent. And you can push this in and do that 4 different times. Okay. I'm going to show you another way. I'm going to show you the quick way I would do this is on my calculator. And I would go to y equals. And y'all, I'm going to put my function in here, 61,000. And then have parentheses 1.00875, close parentheses. And then my exponent was 4t, but on the calculator, you got to do 4x. So it's got my function in there now. And y'all, I don't care about the graph. I'm worried about the table. So I'm going to go to second graph for my table. And y'all let me go down here to, so my first value was 0. Well, at 0 years, if you look at the Y value, I got $61,000. And then next I had T equals 3. So let me go over here, arrow down to 3 on those X's. And at 3 years, I got 67,722. All right, next was 7 years. So let me go over here and arrow down to 7. At 7 years, I got 77,852. And then they wanted me to do 10 years. And at 10 years, I had 86,431. So y'all, like I said, you can punch them all in individually and do like 61,000, 1.00875, close parentheses, and then the first exponent was 4 times 0, and you get 61,000. And that makes sense. If no time has passed, then you got to have what you started with, which was your 61,000. I sort of like graphing them because you can knock them out pretty quick. So here at 0, we had 61,000. Uh, 3, we had 67,722. At 7, we had 77,852. And y'all finally at 10, we had 86,431. So what that means is if you invest 61,000 in 10 years, you've pretty much made about about $25,000, okay? So you made $25,000 just by putting $61,000 into the bank. All right, y'all, so look at this one. On Melissa's 6th birthday, she gets a $2,000 CD that earns 7% interest, compounded semi-annually. If the CD matures on her 11th birthday, how much money will be available? All right, so this is the same type problem. Let's go get our formula set up. All right, y'all, so we're still using our A of T equals our P times 1 plus R divided by N, R raised to the N times T. All right, we know her starting amount was $2,000. Then we got 1 plus R is her interest rate. So 7%, if you move the decimal left twice, you would have to add a 0 and make that a 0.07. And y'all just got to remember, when you don't see a decimal, it's always assumed to be after the number, okay? All right, so 0.07. Semi-annually for compounding. Well, semi-annually would be 2 times a year. And then up here, we would have 2 times our T. So now we got to figure out how much time passed between her 6th birthday and her 11th birthday. Well, y'all, T would equal 11 minus the 6, which would be 5 years. So we put our 5 in. Now this one wants me to round off to the nearest cents. So round to the nearest cent. And that means 2 decimal places. Sort of like money there, okay? All right, y'all, so I'm gonna go push that in and let's see what we got. Now realize it's got to be more than 2,000, okay? Because they started with $2,000 CD. So if it's a good investment, it better be over 2,000, okay? All right, y'all, so let's go push that in. I got 2,000 parentheses 1 plus 0.07 divided by 2, close parentheses, and then my exponent was 2 times 5. All right, y'all, so we'll hit enter. We're rounding 2 decimal places. So that's $2,821. Oh, y'all, look at that. I got a 1-9, but the 9 has a 7 after it. So that means we're going to round that 9 up. Well, y'all, on this one, if we round the 9 up to a 0, we got to turn the 1 into a 2. So a 0.19 will turn into a 0.20. So $2,821.20. All right, y'all, so 2821.20. So basically what that means is Melissa, her CD, her CD in 5 years gained $821, almost $1,000 for her, okay? And y'all, that's all you're doing in that section is you're going through and just playing with some exponential stuff. You had a few graphs, and then the last 2 problems were dealing with the actual formula, okay? Woo, y'all, this is a rough one. Your nose is all stuffed up like mine is. All right, y'all, look at this. 9.4. I'll get us an introduction and then we'll do our break, okay? This deals with logarithmic functions. So logarithm is a new word for you. But basically a logarithm is an exponent. Okay? So I'm gonna give you some terminology here. Log A of Y equals X. All right, y'all, here's the thing about a logarithm. The little subscript A, that is the base or the number that was multiplied to get the result. Y, that is the result. So that's the result from multiplying the base. So this tells you the number you started with. This is the number you ended up with. This little x, remember we said a logarithm is an exponent. So if you take the log of a result like this, x is the exponent that the base was raised to. Okay. So you're not starting out with, say, 5 squared. Let me show you what we got going on. Y'all, let me do one. How about log base 5 of 25? What I'm looking for on this problem, here's my base 5. So that means you got some base 5 sitting here. Now, I don't know the exponent yet, but I know the result from multiplying this 5 times itself, ever how many times the exponent says, the result was the 25. So my question is, how many times are you going to multiply 5 times itself to get a 25? Then y'all, if you start multiplying it out, well, y'all, 5 times 5 is 25. So this logarithm would give me an answer of 2. 2 is the exponent that I would raise this 5 to equal 25. Right? 5 squared is 25. All right, y'all try this one. Log base 3 of 27. So you're starting with a base 3 this time. We don't know the exponent, but we know that the answer was the 27. So let's see. We got 3 times 3. Well, that's 9 times 3. Well, y'all, 9 times 3 is 27. So since I had to multiply that 3 times, the log base 3 of a 27 would give me an exponent of 3. And if you want to check it, put the exponent back. 3 cubed is 27. Are those making sense, y'all?
Yes.
And you just got to realize that you're finding the exponents on those, okay? So let me do one more. How about a log base 7 of 1? So I got base is 7. I don't know the exponent, but that's got to equal 1. And y'all, there's only one exponent that you can raise any number to that'll equal 1. And if you remember back,
Would it be I?
um, remember this one we said a while ago? If this exponent was 0, we got an answer of 1. So any base, I don't care what the base is. If that result is a 1, then the exponent has to be a 0. And y'all watch this. Let's do this real quick. Watch this. 7 exponent 0 equals 1. 5 exponent 0 equals 1. Negative 88 exponent 0 equals 1. 1,999 exponent 0 equals. So y'all getting the point? I don't care what the base is. If that exponent is a 0, then that result is a 1 on those, okay? All right, y'all, so let's do a break. When we come back, we'll play with these logarithms. And the nice thing about logarithms, the calculator knocks those out really quick, okay? So y'all, I'm gonna stop my share, but that's on pause. There y'all, so I'm gonna actually show y'all how to do these on your calculator. You see this one is a log base 2 of x. So first of all, let me show you how to get that log base 2 of x, okay? So let's go to our calculator. All right, we're gonna go to y equals and clear that out. So to get that log base, oh, let me go through something with y'all real quick. Let me just tell y'all a few things about these. On the front of the calculator, you'll see a log button and the LN button. The log button on the front of the calculator is to use a log base 10. So if it don't have a base here, it's automatically a 10, okay? Now this LN that's on the calculator, it is a log base E. That's Euler's number we learned earlier, okay? These two are on the front of the calculator. Any other log, so to get any other log, we hit the math button, and then we're going to arrow down until we get log base. The log base allows me to put in a log with any base, okay? So the one on the front of the calculator, the log stands for log base 10. The LN stands for log base E. Any other log, we got to go to the math button, okay? All right, so let me go see what we was actually graphing again. So this is y equals the log base 2 of x. All right, so the graph is, we go to our calculator. Now, since that's a log base 2, I can't use the log by the 7 and the LN. I've got to hit the math button, and then I'm going to arrow down until I get the log base. Once I got log base, I hit enter, and then it has a subscript. That's where I would put my 2, arrow right, and then I would put my X. All right, y'all, at that point, I hit graph. And notice these graphs make a vertical asymptote sort of with the y-axis. Now you'll notice it don't go on the negative axis at all. Everything's on the positive side of the y-axis, okay? So on that, let's see, we got our picture. So we would go to MathLab. And y'all, the only one doing that would be A. All right, this one is a log x. Now, knowing what that picture looked like, the only one that is doing like that one did would be A. But let's go graph it and see. Now, that one is a log x. And it don't have a subscript, so I would use this log on the front of the calculator by the 7. So I would hit the log, and then I would just put in my x. So if you don't have a base, you're using the log on the front, because technically this is a log base 10, okay? But y'all were going to hit graph. And look, it does the same thing. It's just a little flatter than the last one because we got a 10 there instead of that 2 that was there on the last one, okay? But y'all, that's I think that's what we said was A on that one. So click A, check that answer. And I think there's one more of these. L into X. But y'all knowing what those graphs look like. There's only one graph that it can be. So let's go do the ln of x on our calculator. So go to y equals, clear that out. ln is by the 4 down here. So you would hit the ln, put in your x, and then hit graph. And y'all, I want y'all to notice, they all do the same graphs basically. So when we go to Math Lab, we're going with C this time, okay? Alrighty, y'all. So this one has a base 8. So guess what? We're going to do the calculator. Oh, let me get my numbers again. All right, y'all. So this is a log base 8 of 4,096. So how many times do I got to multiply 8 times itself to equal 4,096? Well, y'all, let's go ask our calculator. We're going to hit math, arrow down to log base, hit enter. Our base was an 8. Our result was 4,096. All right, y'all, when we hit enter, we get an exponent of 4. So that means 8 times 8 times 8 times 8 equals 4,096. There, y'all, so we got a 4 there. And then we go to the next one. Log 3 of 27. Oh, I think I did that one on my examples. But going to the calculator, hit math, go down to log base, enter. We had a 3 for the base, 27 for the result. So how many times do I multiply 3 times itself to equal 27? That would be 3 times. We'll come in and put a 3. All right, y'all. So this one, it's a log base 10 of a 0.01. So let me show you. There's 2 ways you can do that one. Remember, this log on the front, this log is a log base 10. So if you use that log, all you got to do is put in the 0.01 and enter. You get a -2. Or you can do the log base by hitting math, arrow down to log base. You can put the 10 there and then do the 0.01. When I hit enter, I still get a -2. So if your base is a 10, you got options on that one, okay? All right, y'all, so we would put in our -2 and then move on. So y'all, this section is just doing a lot of calculator stuff, okay? Log 3 of 1 over 81. Now, when you got fractions like this, you should end up with negative exponents. So let me go here. I'm going to clear everything out. So I need my log base. So hit math, arrow down to log base. Enter. I had a base of 3. And then I had 1 over 81. So 1 divided by 81. All right, y'all, we hit enter, we get a -4. So notice, when you got like 0.01 like I had a while ago, where you got fractions, you're going to end up with negative exponents, okay? ln of 1 over e. All righty, so the front of my calculator, I got the ln. So hit the ln and then do 1 divided by. So since I just need an e, I'm going to hit the second and then divide and get my e. And y'all, when I hit enter, I get a -1. So remember, that's a fraction again, so you get negative exponents on the fractions. All right, y'all, let me pull my chat up. Why don't y'all do this one? See what y'all get when you do the log of 1/10. So this one, you could use the log on the very front. That's by the 4 there. And remember, that's a fraction. So y'all should end up with a negative exponent. All right, y'all, so let's go to our calculator. So we got a log of 1 divided by 10. Hit enter, and I get a -1. So log base 5 of 5 squared. So let me give y'all a little property we got on these. A few properties on these logs, okay? Log base A of A to the B equals B. If the base matches the base raised to an exponent, the answer will always be the exponent, okay? Another property on logs. No matter what the base is, we said if that results in 1, then that log would equal 0. So if there's a 1 here, you got to get a 0 on that, okay? So log base A of A to the B will always equal B. Log base A of 1 will always equal 0. All right, so let's go back and play with that. So this is the log base 5 of 5 to the second. So this should equal 2. But y'all, we can do that on the calculator. Let's go to our log base. So hit math, go down to log base. All right, we had 5. And then the answer was 5 to the second. So log base 5 of 5 to the second, when I hit enter, equals 2. So if the base of the logarithm matches the base raised to an exponent of the result, then the answer is always that result. But y'all, what's nice is all these, you notice I'm doing them all on the calculator. Log base 81 of 3. All right, so log base 81 of 3. Now, when the base of the log is bigger than the result, we're going to get fractional exponents. So let me go get my log base. I had 81 for my base, 3 for my result. That's going to give me 0.25, but we got to turn that back into a fraction by hitting math and enter. So y'all, that equals 1/4. All right, y'all, we know this answer quick. Log base 8 of 1 is 0. Anytime that results in 1, that exponent has to be a 0, okay? All right, new stuff. Here we go. So y'all, we're going back to the pad for a second. All right, so this part we're going to be converting to logarithmic and exponential equations. So you got to go off of this property. Log base A of y equals x if and only. So these arrows means if and only. So if and only if a to the x equals y. So this is how you convert from a logarithmic to a exponential, or from an exponential to a logarithmic. This side is logarithmic. This side is exponential. But notice, the base of the log becomes the base of the exponential. The result of the log is the result of the exponential. And remember, log base A of y gave me the exponent of x. Well, there's my exponent of x. So I'll just use these conversions right here to go back and forth. So keep that handy for these next few examples, okay? So they want me to convert to a logarithmic. So I got to write my log, Log. And y'all notice when you write log in, it'll highlight it for you. Now, you got to come down here and hit that little subscript. The base of the log is equal to the base of the exponential, which was the 10. And then you go to arrow right. The result is the 10,000. And that's going to equal the exponent of a 4. So y'all, I just made that conversion going off of what we just made. Remember, the base of the log is the same as the base of the exponential. The result of the log is the same as the result of the exponential. And then that equals 4, which is the exponent. And 4 was the exponent of the exponential. All right, convert to a log. So we're going to write log. Then we're going to come down here and get our subscript. So the base of this log is the base of the exponential, which is 3125. Arrow right. The result of this is the result of the exponential, which was the 5. And y'all, that's going to equal the exponent, which was a 1 divided by 5. And y'all, what they're trying to do, they're just trying to throw some big numbers at you in fractions to try to confuse you. But just remember, we're going straight off of that if and only if conversion, okay? All right, y'all, let's see how we do. Write log, because we're converting to a log. Go down here and get your subscript. The base of this log is the base of that exponential. And y'all, that looks like a Q. Then arrow right. The result is the 21. And that's going to equal the exponent of a W. So y'all, wish y'all get into these conversions. They're not too bad, okay? All right, now they're going to go the other way. We're going to convert these logs to exponential. So the base of the exponential is the same as the base of the log. So that's going to be the 4. Then we come down here and get our exponent. The exponent is the 2. And y'all, that 4 to the squared has to equal that result of 16. Okay? So you just got to remember that 2, or these answers of the logs, those are the exponents, okay? Now, look here. ln of 90 equals 4.4998. There's not a base on this, but remember I said a ln was like a log base e. So the base down here is the e. The exponent, so let's get our exponent, is the 4.4998. And then that's going to equal the 90. So y'all just remember, if you got an ln, that is a log base e. Oh, so we just had to do one, do it that way. All right, y'all, these are on the calculator. They just want me to figure out what the log of 38 is. We're going to round it 4 decimal places. So since there's not a base there, we can use the log that's on the front of our calculator. All right, so log, what was that, 98, I think? So log of 98 will equal 1.9912. So I would keep that a 2 because the 2 after it. All right, so 1.9912. Oh, mine's a log of 38. My bad. Let me go back. All right, so log of 38. 1.5797. Ooh, I got an 8 after that. So that'll be a 1.5798. 1.5798. Ooh, these are tricky because you got to round them off that 4 decimal places. All right, y'all, log of 59. That's on the front of your calculator. Hit the log, 59, enter, 1.7708, but I got a 5 after it, so that'll be 1.7709. So 1.7709, I think I said. So y'all look at this one. You got a log, that's really a log base 10. But I got a result of a negative 66. So is there a way that a 10 can be multiplied to get a negative number? Because remember, that's a log base 10, so 10 times 10 is 100, that's positive. There's nothing I can do to that to make it negative. So y'all watch what happens on my calculator when I do the log of a negative 66. I get whoops, let me switch my mode back for you. I want to get back into real. Look at that. You get an error that says non-real answer. That's why the answer it gave me a while ago was imaginary because it had that eye on it. If you was to look at this answer up here and arrow out, you would see that it has an eye at the end of it. So that means it's imaginary. So We cannot take a log of a negative number. So on Math Lab, you would put the answer does not exist. There's nothing I can do to a 10, multiply to 10 times itself to make it a negative number, okay? So remember that. We cannot take a log of a negative number. All right, then I need to do some of these with LN. So the LN of 42, for y'all, that's on front of our calculator. We got an LN button, and then put in our 42 and enter. So let's see, 3.7376. But I got a 6 after that, so that's going to be a 0.7377. So I got 3.7377. 3.7377. Well, it's hard to remember these decimals going from one screen to the next. Y'all, same thing. You'd punch in LN 558.7, LN 558.7. So let's see, 6.3256. I got a 1 after that, so I leave that alone. So 6.3256. All right, 6.3256. So what do you think this answer is? LN of a negative number. LN of a negative 1.26. See, y'all, LN's on the front of this calculator. Oh, I forgot my number. Let me go back. All right, so that's an LN of a negative 1.26. We all we know what the answer is going to be. So LN negative 1.26. So remember that's a base E. There's nothing I can do but multiply the E times the E times the E to make it negative. So when I hit enter, I get an error because it's a non-real answer. So that means it does not exist in the real world. All right, y'all. Now the last thing you had to do on that was just graph two graphs. But y'all, one's exponential and one's a logarithmic. We know what the exponentials and logarithmics do. If the red's the exponential, remember the exponential graph went uphill left to right and crossed through 0, 1. The logarithmic graphs came up the y-axis, crossed through 1, 0. So the only one that looks like what we need is A. But y'all, we can graph these. So I'm going to graph them in my y equals, okay? So let's go to our calculator. Go to y equals. So the first one was 2 to the x. So I got 2 exponent x. All right, then I go down to y2. That was a log base 2 of x. So hit math and go get that log base. So the base was a 2, and then you got your x. So watch when I hit graph. There's my exponential, there's my logarithmic. And y'all, that looks pretty much like that A we were looking at. So you click A and check that answer. So y'all, this section here, 9.4, is to get you good at being able to find logarithms on your calculator. And the LN is what we call the natural log. and it's a base E. So let me go put them on there for you. So just a recap of the log stuff. Like I said, the log on the calculator is a log base 10. This is known as the common log. The ln is a log base E. This is known as the natural log. Now, what messes a lot of people up on the calculator, they'll do that. Well, they mess up. That's not an I, that is a little L and an N. That's a LN. Once you write this in right, it'll highlight it and make it bold on the calculator. If you accidentally did a capital I and an N, it wouldn't make it bold, okay? So just remember, this is a LN, not a IN, okay? All right, y'all, so what'll be coming up? Tomorrow we'll do 9.5. This is properties of logarithms. And these properties of logarithms, remember, logarithms are exponents. So these properties of logarithms, they sort of mirror the properties of the exponents. So we learning this tomorrow, and I think we'll do some support with it tomorrow. So this will be Thursday. And then Friday, we'll knock out 9.6 and 9.7. 9.6 deals with equations. These are logarithmic and exponential equations. And then 9.7 deals with some more of those interest type problems. But instead of having like semi-annual compounding and quarterly compounding, these deal with continuous compounding. So this section is pretty quick. It only has like, I think, 5 questions or so. So tomorrow, properties and logs, and we'll do some support. And then Friday, 9.6, and then 9.7. And y'all, this finishes out test 4 material, okay? So that means next Monday, I will review test 4. And then that way, Tuesday and Wednesday, we can review for the final exam. And the final exam is due Thursday, August 1st. Okay, so basically next week will be a couple tests, and we'll spend Monday, Tuesday, Wednesday, and that's all we're gonna do is get ready for this test and that final exam. So we will finish out Thursday and Friday for the test 4 material. Well, all right, y'all, any questions?
No.
Well, I don't know if I sounded pretty nasally today, I think. All right, so all right, y'all, so let me quit our recording.